My name is Akio Kasuga. I will chair this session, and also we have two co-chairmen, Dr. Matthew and Dr. Ono. Let me introduce really myself. I belong in the Sumitomo Mitsui Construction Company. I'm a bridge designer, and today we have three presentations. And each presentation have 15 minutes, and we have 10 minutes discussion, up to totally 30 minutes. So I'd like to we have a very attractive, very positive discussion between the professional and another PhD candidate, and also the people from academia. So. First, the presentation is Masonry strengthening and the combined action of the vertical and horizontal forces by Mr. Usenko.
Good morning, dear participants. Good morning. Nice to see you here. And as you can see, the title of my today's work is Masonry Strengthening Under the Combined Action of Vertical and Horizontal Forces. As you can see, I am from National University Юрій Кондратюк, Poltava Polytechnic. Oksana Dovzhenko, Vladimir Pogrebnin, Alexander Zima are also authors of this work. And let's start. So, the aim of the study, which is being carried out, is to improve the methodology for calculating the bearing capacity of stone structures under the combined action of horizontal and vertical loads. Building with load-bearing brick walls are widely spread in civil engineering. They, as a rule, are under the combined action of vertical and horizontal loads. Among the latter, seismic impacts play the most significant role. The territory of Ukraine is located in three seismically active zones, which include the southern coast of Crimea, Transcarpathia, North Coast and Carpathians, and the most powerful, one of the most seismically dangerous, the Romanian Branch Zone. It is here that the power of earthquakes can reach maximum from 6 till 9 points. So, an analysis of the effects of earthquakes made it possible to identify the main damage patterns of brick structures. Depending on the direction of application and the rate of the horizontal and vertical components of the load. As you can see, they are given on the screen. You can find them on the screen. And one of the most vulnerable structures of brick buildings are the separation partitions. Here, let's talk about stages of deformation of brick walls and methods of their calculation. So on the screen, you can see the separation partitions of the buildings during operation can be at different stages of deformation. Three stages are given over here. Let's talk about them. At the first stage of masonry deformation, you can see it over here. When seismic forces are small, separation partitions work together with a window band over the entire contact area. The vertical load is transferred from the upper separation partitions to the lower along the entire horizontal section. Subsequently, in the tensile zones of the horizontal section of the separation partitions at the levels of the upper and lower part of slots, adjacent to them, cracks form. The masonry monolithic is broken. This is the second stage of work. At this stage, the transmission of vertical and horizontal loads in the inclined sections is carried out only at the length of A sub C over here, smaller than 2A's, where A is the half of the width of separation partition. As you can see over here, 2A's is the whole separation partition, and 1A is the half of it. When and alternating horizontal loads due to the formation of cracks, adhesion in the masonry is broken along the entire contact above and below the separation partition. The third stage over here, which you can find, is characterized by a reduction in the length of the compressed zone and the formation of a diagonal crack in the separation partitions over here. And at the top of the slide, you can find the scheme of separation partitions damage under the combined action of vertical load and horizontal seismic load. According to Salaman-Pour, in the case of shear forces in the horizontal plane, the following types of failure are the next. Here, shear sliding along the horizontal line, shear sliding along the broken line, displacement with splitting, and crushing by bending. The most common monolithic masonry orientation under the combined action of vertical and horizontal loads is failure along an inclined section. So, as the theoretical base for calculating the strength of a wall under the combined action of vertical and horizontal base, the application of the theory of plasticity is promising. The preconditions you can find on this screen, and they are: for masonry in a stage of destruction, the assumption of plasticity is applied and a rigid plastic body model is used. The development of kinematic mechanisms in pseudoplastic bodies is associated with the formation of the thin layer of localization or irreversible strains. And a quantitative criterion for applying the theory of plasticity to stone structures is the possibility for at least a momentary extent of the plasticity condition over the entire area in the limit state of the masonry, the development of which is necessary for the transformation of the body into a kinematic mechanism. On the slide number 7, you can find the relationship between strain rates and stresses is found from the associated law of yield. Here you can find this law of yield. The character of the stress strain state of the reinforcement is taken depending on the state of the masonry that surrounds it. Let me also tell you about the variational calculation method. Problem solving in discussions in discounting velocity functions is used. At the National University Yuri Kodranchuk Poltava Polytechnic, a variational method in the theory of plasticity is developed to calculate the strength of masonry during crushing, splitting, and shearing, which is based on the consideration the failure stage that takes into account the complete set of influence factors. Diagonal failure can be considered as bilateral crushing, splitting, or just shear cut-off masonry. In this case, the failure surface consists of two shear planes along the edges of the verge, which is formed under the loading platform and the failure splitting areas connecting the corners of the verges. An important issue in the application of the technique is the designation of the dimensions of loading platform significantly affects their strength. The masonry strength condition of Baladin-Guinier is accepted as the plastic potential, which in tensor form has a simple expression, which you can find over here, the formula number 2. Under two-dimensional stress state, this condition is geometrically an ellipse. The functional of the method for a stone element in a two-dimensional stress state will be the formula number 3. So let's talk about masonry reinforcement. For increasing the bearing capacity of brick walls, the most effective are measures to contain the transverse strains of the masonry. Modern technologies of the international concern SICA allow us to create and apply new materials with enhanced mechanical properties such as carbon fiber ribbons as reinforcing elements. On the slide number 11, you can find that during diagonal crushing splitting, the strips are placed horizontally or in a direction perpendicular to the direction of the crack development. During calculating, the reinforcing is considered as external reinforcement. An additional term is introduced into the functional or the variational method, which takes into account the deformation capacity of carbon fiber at given speed. So, on the slide number 12, the limit of failure resistance under the loading platform expressed through unknown parameters k and tan theta and can be calculated using the formula represented like at the number 4. So also let me show you the results of calculating the characteristic values of the relative strength of the separation partitions by the variational method in the theory of plasticity for given ratios of horizontal and vertical loads. They are given in this table number 2. So to select the reinforcement and the value of the compression stresses sigma c is equal to the sum of ns divided by th, where n sub s is equal fyd multiplied by a, means area. It is recommended to use the previous formula, this one, and the data from table 2 to subject to condition alpha local multiplied by fd multiplied by TL local should be larger than n, larger or equal to NED. The analysis of the character of the failure of separation partitions, the kinematic scheme and the data from table 2, which you can find over here, shows that the maximum level of compressive stress of the masonry should not exceed the rate of F sigma to Fyd should be equal or smaller to 0.7, which you can find over here. To increase seismic resistance in order to include it into work of masonry should not exceed this ratio. Okay, to increase seismic resistance in order to include it into work of masonry sections under the slots, the angle of inclination of the diagonal of the separation partition to the vertical should not exceed the value of the direction angle to the resultant load. To reduce the influence of stress, concentration, and increase the strength of the compressed masonry directly under the lintel, the length of its area of bearing is recommended to increase compared to building operated in non-seismic regions. And finally, on this screen, you can find the conclusions. I will read for you those conclusions that effectiveness of reinforcing stone structures is largely determined by the accuracy of the calculation. The use of the variational method in the theory of plasticity makes it possible to justifiably determine the value of compression stresses necessary to ensure the strength of the masonry under the combined action of horizontal and vertical loads and to designate the final gain solution. The resistance of the masonry separation partition under crushing splitting is affected by level of compression stresses and the length of the lintel area of bearing. The most effective masonry works with compression sigma is equal to 0.7 Fyd. Increasing the width of the lintel area of bearing increases the bearing capacity of the separation partition. During the new designing, restoration, and reconstruction of exciting earthquake-resistant buildings, with bearing of stone walls, it is recommended to set the dimensions of the separation partitions with the condition that the ratio of the width of the separation partitions to its length doesn't exceed the value of the horizontal to vertical ratio B to H should be larger or equal to SED divided by NED like it given in this table. On this, my presentation is over. Thank you so much for your attention. I can hear your questions.
Thank you very much. Thank you, Mr. Usenko. So I have a question, one question to
Yes.
you. And you mentioned about sigma over FD, the optimum value is 0.7.
Yes.
And so if you strengthen the masonry structure, masonry walls by using the carbon fibers, carbon ribbons, like which you showed us, and if in this tables, how do you determine? How do you decide the value of the maximum value of the 0.7? So if you have a over 0.7, the failure mode is changed from the shear failure to the stripping on the bottom. So please explain a little bit more.
So here we have only 0.7 because if we will take the relative compression stress over than 0.7, it will be expensive and the relative compression stress will be go down. That's why the 0.7 is the most optimal value, because after 0.7, for example, larger than 0.7, it will be more expensive but not so effective.
Okay, so you determine the value in the cost of the strengthening. Okay, I understand.
I just wonder to know if you, in your PhD, you make some tests, because you show us some picture of a test, but I don't know if you made the test and did you really compare your results to the test?
So here we during my PhD thesis we done some experiment, and during that experiment I applied my calculations, my work to that experiment, and my calculations proved that my calculations helped to understand the experiment that the diagonal crack will be exactly like here. As you can see here, let me take the red dot. Here is given the character of the failure. It's separation partition between two windows, and the crack will be like that. And strengthening of this crack, I propose to make using the CCAS tape and put it perpendicular to this crack, because as you can see from the scheme, inside of this crack the forces will be like that. As you can see, this place is here, it's over there, this crack is over here, and this is over here. Two unknown parameters. Unknown parameters are tan gamma, let me show you in this formula, and I will take the red dot again. Tan, gamma, and k are the unknown parameters, and the strengthening of the for the separation partition in this formula is given over here, where k is equal to the ratio of V1 to V2, where V1 and V2 are the speeds of rigid disks 1 and 2. Let me show you those disks. Those disks are at this screen. Here is one rigid disk, and here is another rigid disk.
Okay, thank you.
Thank you for your question.
So do you have any application to use this technique in your country?
Here I can show you that example of applying reinforcement tabs for international concern seeker. Here is given the real wall, which was applied to the reinforcement tabs. And in my town, this is Poltava, we have some of the buildings which reinforced using some tabs. They are historical buildings. We can't apply there some metal reinforcement because it will break the exterior of that building. We applied the reinforcement using the tabs from inside part of the building.
So you strengthen the buildings in the both sides?
In the inside side of the building. Yes, inside, because one of the advantages of applying the reinforcement tabs is that we don't disturb the outside part of the building. We are making the reinforcement from inside part of the building. Of course, we can make the reinforcement from outside part of the building, but it will break the exterior of some historical building, for example.
Okay, okay. So in your research, so your research is almost finished, or you have something to check, to investigate a little bit more when you finish your PhD?
Yes, I am a second year PhD student. I will study during 2 years, and that's why I have some things to do. That's why my research isn't finished. And frankly speaking, I think even after my finishing my PhD, I will still make some researches because this is a very deep and interesting topic in which I can research during all my life.
Okay, so please do your best. And
Thank you so much. Thank you for this conference.
All right. Okay, thank you, Usenko. So I'm looking forward to see the complete research of your project in the future. All right, thank you very much.